Cool. So picking up where we are off last time. So use a trig function to find each value of x. Round to the nearest tenth if necessary. So tenth, aka the decimal place right to the right of the period. Literally one decimal place. That's all we want. That's a tenth. All right. So let's label what we have. I have a 30-degree angle. I have the adjacent side, and I'm wanting to find the opposite side. So which trig function should I use?
Well, if you start with 30.
Which trig function should I use?
30, 60, 90.
We do know it's 30, 60, 90. So there's two ways to use this. There's two ways we could do this. The first way I'm going to show you is with SOHCAHTOA. The second way is showing you with like the rules of 30, 60, 90. So let's do a trig function first. Which trig function should I use that has opposite and adjacent? Tangent. Okay. So tangent of 30 degrees is equal to opposite x over adjacent 7. If I multiply by 7 on both sides, 7 times tangent 30 degrees is going to be 7 over root 3, also known as 7 root 3 over 3. And as a decimal, what would this be? If you take 7 tangent 30, what is it?
Oh my god. He focused on the math.
Nearest tenth, what would this be?
Oh, I know.
4.0. Okay. All right, so 4.0. Let's make sure we get that answer in the other way. So let's see, if this is a 30 degree, I want to know what the short side is. And I know that x times root 3 is the one that's across from 60 degrees. Coolio? So the side length across from 60 degrees is just going to be your short side times root 3. So this means my 60 degree leg is 7, and I know that's going to be root 3 times my short side. So how do I find what my short side is? Divide by root 3 on both sides. What's 7 divided by root 3?
4.
Did you do it in your calculator?
No.
So I'm trying to prove to you guys what this is. So they plugged this in and said this was 4.04. If you plug in 7 over root 3, you get... Why is there one person calculating? Huh? 4.04?
Yeah.
Yeah. So rounding to the nearest tenth, you get 4. So I want to show you two different ways. First, recognizing that we have the adjacent side and we have the opposite side. So we can use tangent because tangent is the ratio between opposite and adjacent. So tangent of 30 is x over 7. To get x by itself, multiply by 7 on both sides, plug this in, we got 4.04. I cheated a little bit because I knew tangent of 30 was 1 over root 3. So 7 times 1 over root 3 is 7 over root 3. So you get the same answer that way. Versus here's our special 30, 60, 90 triangle. I know across from 30 is the x, the length of the short side. Across from 60 is the short side times root 3. Since I know this length right here is 7, I said, okay, 7 equals x times root 3. Finding the length of my short side, divide by root 3 on both sides, and I get the same answer. So that's two ways to do the same problem. So like, you are a, I don't know, you're a contractor. Look at you. You have a big toolbox with all this skills. Teaching you all the skills to solve a triangle. All right. Let's keep going. Let's try this one. So I have this 20-degree angle. Let's label the sides that we have. What sides do I have? Hypotenuse and the opposite side. X is the opposite side, right. So using SOHCAHTOA, 100% expecting you to remember SOHCAHTOA, which is why you're going to see it 50 times before your test. So sine of 20 degrees is going to be the opposite side, x, over hypotenuse, 32. So multiply by 32 on both sides. Good.
It's 10.94, but you round to the nearest tenth. Right?
So what was the original one? 10.94?
Yeah.
So rounding to the nearest tenth, 10.9. Okay, I feel like we're getting the hang of it. Try the next part. I have 49 degrees. Let's go ahead, let's label our sides that we have. So I have the adjacent side is x. The opposite side is 17.
So 10.
So I'm looking for tangent. Tangent of 49 degrees equals opposite 17 over adjacent x. Ooh, tricky trick. Yes, Lana.
Just like kind of off, but it doesn't matter that the triangles have to equal 180. Because like the first one.
It did equal 180.
Well, it was 20 and then 90, so like
So what would make the other angle?
it's like
50 or 70? Yeah, this would be a 70-degree angle.
does it matter?
I could have used 70 degrees and used cosine. If I would have used 70 degrees, I could have used cosine because I have the adjacent hypotenuse.
So you just multiply by 1/7.
Okay, so down here, how do I get x by itself?
Times x.
Okay, so I'll multiply by x on both sides. So x times tangent 49 degrees equals 17.
Divide by 10.
And then divide by tan of 49. So notice I'm dividing the whole thing by tangent of 49. Not dividing by tan, not dividing by 49. Literally tangent of 49. Tangent of 49. So x equals 17 over tan 49.
X equals 14.7. Wait. So you multiply by x. 14.8. Sorry.
So multiply by x on both sides because I don't want it to be on the bottom of my fraction. And then I divide by tan of 49 on both sides. This allowed the rearranging, so x would be on top.
Yeah.
Because the number one thing people do wrong in this situation is, oh, divide by 17, that's my answer. No, that's 1 over x. That's not x. That's the reciprocal of x.
I understood why you multiply by x, I just show which stuff you did.
Okay. That was the first thing we did. Yeah. Sweet. Let's keep going. Do we need to pause a second? Are we doing all right?
Maybe a minute.
Yeah.
Is it like 4 minutes?
Yeah.
Okay. You said 4 minutes. Fun
40
one.
minutes, my bad.
I literally let you guys out 2 minutes early the last couple times. All right, inverse trig function. So reciprocal, meaning reciprocals, you just flip it. Inverse, you're doing the opposite. So what's the inverse operation of multiplication? Division. Inverse operation of subtraction.
Addition.
Inverse operation of sine.
Cosine.
Sine inverse. That's right.
Come on.
Inverse trig functions are used to find the measure of an angle. So you use this when you're solving for the angle. So far, we've been solving for side lengths. All right, so let's go up here. In these last two problems, notice how we had x on top, we had x on bottom. What if we don't know what the angle is? Right? There's literally 3 things that I can ask you for. I could have the variable on top, on the bottom, or I could ask you for the angle. So if you don't know the angle, I give you all 3 sides of the triangle. You don't know the angle. Issue. So we could figure out the angle.
With the sign to the right.
Right, so in order to get rid of sine, you cannot just divide by it. What you have to do is the opposite operation. So if you take, oh my god, if you take sine inverse of sine of x, and you have to do it to both sides, so sine inverse of 1/2, so I'm just looking at this guy right here. Sine inverse and sine will cancel each other out, and I'm left with x equals sine inverse of 1/2. So if you put that in your calculator, so you click trig on your calculator, and you see how the top row is all the trig functions, and the bottom, the row below that are the inverse. So it literally looks like sine to the negative 1 power. More or less, that's what it looks like. So I want you to put this in your calculator and see what you get. If you're solving for the angle, you're going to use the inverse operation. So if you put sine inverse, you'll get 30. That will give you the angle. Alright, so we still have a minute, so we can do example 5. Find the measures of angle A and B rounded to the nearest tenth. So if I wanted to do sine of angle A, how would I go about this? Sine is opposite over hypotenuse.
So 9 over 17.
And then I need to do sine inverse on both sides. So I find the angle is going to be sine inverse of 9 over 17. So what would that be? So it's very important when you're in math class, bring your calculator. 32.0. And this time, you do have to have the degree because the answer is in degrees. So you must have it. We do need to find angle B. Well, I mean, like 10 more seconds. So if we go through and do sine of angle B, opposite, so 14.4 over 17. You see that angle B is going to be sine inverse of 14.4 over 17. So as soon as we finish this, we'll be done. What would this be equal to?
I don't know.
57.89. So 59. 57.9.
57.89, so 57.9?
Yeah.
I don't know why that happened. Alright. So I'll see you guys tomorrow. We'll finish the notes and then we'll work on problems.